bound my other two variables. R. What is my radius in between? 0, right? Because I'm shading this entire center, and it's 0 out to 1. Okay? If I want to do theta, I want the entire circle. What am I going to run theta in between? 0 to pi. Which means that when I go to set up this entire integral, 1, 2, 3. Go ahead and put my differentials here. I really need to be careful about exactly what I'm integrating. That's exactly what I'm trying to find. We set up our bounds so far, right? Let's go ahead and put them in. 0 to 2 pi, 0 to 1, and 4, right? The only question here is we got really excited, but we actually haven't even been asked to find anything yet, right? Questions on what we found our bounds? Are we okay with it? Yeah.
Wouldn't R be different once we got down to the delta?
Yeah, but what's really cool about it is that when we take into account this, notice this has that R in it, right? And so by doing that, by evaluating it with the R, the function changing there, it'll impact what happens when you get that lower portion of it. So really good question. Very good question. Okay, so we set it up. Let's actually put a question with it. Find the mass of a solid given that the density is directly proportional to the distance from the origin in the xy plane. And this right here is the reason I put it up after we had gone ahead and found our bounds. This adds a whole new dimension to it, a whole new set of things that we need to concentrate on. My big question is, did we have trouble finding our bounds? Were there any questions about that portion of this? No? Okay, so we've got that set up. All we need to do is put in our function. We know that in general, if we want to find the mass of an object, what we really need to do is take the triple integral over our solid E of rho x, y, z, right? Everyone's okay with that part of it? dv. This will give us our mass. Does this give us a density function? This problem over there gives us a density function. No, it just says it's directly proportional. Now, a quick review here. If, let's do some good ones. If, what it is, if M is directly proportional to N, the equation of variation is given by M equals K times N. Directly proportional means that as one goes up, the other one will go up for us as well. That is, and I need to be very careful about this. As the size of one goes up, the other goes up as well. Key to this here is K, which is the constant of variation, or sometimes this is what we call the coefficient of variation. Something that varies directly would be how much you pay for gas as how much gas you're putting in your car. If you put more gas in your car, what happens to how much you pay? Goes up, right? If you put less gas in your car, the amount you pay goes down. As this changes directly in the same manner. This can be compared to inversely. The equation for inverse variation is m equals k over n. Because what happens as n gets big? Overall fraction gets smaller, right? So an example of something that varies inversely would be the amount of people you have working on a project and the amount of time it takes. If you're trying to paint a house, if you have 20 people, it's going to take you less time than if you have 2 people, right? More people, time goes down. That's inverse variation. So what we have over here is direct variation, right? As one is changing, the other is as well. So what I want to think about here is the fact that we have rho x, y, z, and what we're saying is the density, that's what rho is, right, varies directly as the distance off the origin in the xy plane. So what I need to think about this here is I know the equation for variation is k times something, right? K is the coefficient of variation, the constant of variation. So what I really need here is the density varies directly as the distance off of 0, 0. How can I find the distance off of 0, 0? I need to take the square root, right? The distance formula is the square root. And the distance between points is x minus, and well, where am I taking the distance off? 0, right? Squared. Plus y minus 0 squared. Now it's important to realize that I'm taking x minus something, because if I had said it varies directly as the distance from the point 1, 1, then we'd have x minus 1 and y minus 1 in there, right? So these are the points that I've off up here. So what I have here is x squared plus y squared, right? So in total, rho is equal to k times x squared plus y squared. Do I know what the coefficient of variation is? No. I don't know if it's a big amount of variation or a small amount of variation, right? But that's not a problem because k is just a constant, right? So it's just going to hang out the entire time. What this gives me is my density is equal to some constant times the square root of x squared plus y squared. This will give me that density function that I'm going to integrate. So what we're going to do is we're going to take this junk and I'm going to put it over here, but I can't just slap it down in there. Why not? Why can't I just write k x squared plus y squared under the root?
It's not polar.
Not polar, right? So the question is, what is this junk right here? What is square root of x squared plus y squared? R, right? Because I'd have r squared under the square root will give me r. Now, in general, you guys, actually we'll really quickly before I say this, what are we missing? We need another r, right? So I'll put this here, and I'll put above it, this is rho times r. In general, when you take the square root of something squared, in general, this is not r. This is really important. I want you to think about this there. If I had negative 2 squared under the square root, I don't get negative 2 out, right? What do I get? Positive 2, right? Same thing if I square 2 and then square root it, right? I would get here 2 as well. In general, when we square something and square root it, we don't get the original app. We get whatever the absolute value or the positive side of that is. Why don't we have to worry about that here? I want you to think about it. I don't want a direct answer. What do we know about r? It measures what? Distance. So do I have to worry about running into this type of situation? No, because it's positive, right? So it's because r measures that radius that we're actually allowed to do that here. Okay, we've got all this junk. Let's go ahead and look at it. I have 0 to 2 pi, 0 to 1, 1, 1 minus r squared, 4, k, r squared, dz, dr, d theta. You guys feel that you can evaluate this?
Yes.
I'm hearing yes from Aubrey. You guys?
Yeah.
Okay. In reality, I would love to evaluate this, but I think it's the easiest part of it. So what I'd really like to do is look at another one. So what we're going to do is we're going to erase this. We set it up, right? We can find this. Really quick question. Do I have to leave that k in there?
No.
No, I can pop it all the way out to the outside, right? Okay. So what we want to do now is talk about converting. So it's converting rectangular bounds into cylindrical coordinates. So we're going to have to look at an example. We're going to look at negative 2 to 2, negative root 4 minus x squared to positive 4 minus x squared, square root x squared plus y squared to 2, x squared plus y squared, dz, dy, dx. Why should this scream polar coordinates? Okay, I've got one over there. Someone else tell me. Aside from the x squared plus y squared, what else? This, even this. Why does that kind of hit that maybe I want to do more from it? Going from 2 down to negative 2, right? That combined with this, I'm thinking maybe I've got a circle, right? That goes from 2 to negative 2 or something. So this type of thing, I'm seeing a lot of squared, a lot of square root. Why else might we want to convert this to polar coordinates? Because it's going to suck, right? I mean, I've got so many square roots, they're just awful. So I want to convert this over to cylindrical coordinates, which means the first thing I need to do is draw it. When I convert over to cylindrical coordinates, do I need to be worried about z? No, because z converts directly over, right? So I can leave z. Z I know is bounded between 2 and square root of x squared plus y squared. We'll deal with these in just a minute. I'm going to leave it for now. Well, I'm going to draw what I have for x and y. So I'm going to draw out the trace in the xy plane. Now, I know that y over here is bounded between negative square root 4 minus x squared and positive square root 4 minus x squared. Now, as is, this doesn't tell me a heck of a lot, so what I'm going to do is I'm going to bring it over here. I'm going to look at the upper bound. That is, y is equal to 4 minus x squared. That by itself might be hard to visualize. What can I do to both sides to make it easier for me to see? Square it. Y squared equals 4 minus x squared, and suddenly, it's a circle, right? What's the radius of the circle? 2. And unfortunately, y equals the square root of 4 minus x squared doesn't give me the entire circle, though, right? Gives me the positive y values, right? So the top half of the circle. That says y equals positive, so that'll give me the top half of the circle. What will this negative give me? Bottom half. So I'm going to sketch it out, bottom half of the circle. All good? Now I need to check that my x bounds make sense too. Does that make sense with what I have drawn? Alright, so I have a circle of radius 2, right? Once I have it drawn out, the next thing I can work on doing is converting the bounds. Okay, let's talk about, first of all, what's going to happen with z. Can that 2 on top stay?